Hello everyone, welcome to our pre-calculus class. This is our lesson 6. In this lesson we will discuss the sine function, how to graph it, then transformation of the sine function, then we have finding the amplitude and period of the sinusoidal function. So let's see, these are the agenda, graphing the sine function, then these two topics are from the transformation, and this one is amplitude and period of the sinusoidal function. So let's start. First of all, by plotting the this sine x, this sine function, actually we can graph it. Actually, it's just simply the way we graph y equals to just simple y equals to suppose x plus 1. Hmm. How do we graph this? How do we graph this kind of equation? First, we consider some value of x, then we do the calculation for here, what we get for y, then we just plot it on the graph paper, then we get the graph. So for the sine function also we can actually follow the similar things, because this is our x, which is our input. This is the input or argument of the function. We can put our values, different values of the sine functions. We can just put here and check what is the value of y. So sine 0 degree equals, suppose sine 0 degree equals to what, sine 30 degree equals to what, sine 90 degree equals to what, then all this value we put here. So this is and this one is 5 pi into 6, 5 pi by 6, 5 pi into 6 is 5 into 180 divided by 6. So this is 150 degree. So this is 150 degree. These are the values for different sine functions. Sine 150 degree equals to sine 150 equals to 0.5. Sine 150 degree equals to 0.5. So we can actually choose the different values of sine in any particular interval, whatever you want. Actually, you can take it whichever you feel like. Okay, this is the best way to draw it. See, suppose you start from 0 degree here, 0 here, then let's say this is your pi, and this is your 2 pi. Suppose this is your pi, this is your 2 pi, this is pi. Then that means this is pi by 2, this is pi by 2. This is pi by 2, and this is 3 pi by 2. So this way we can set our angle. So you can write here 90 degree, 180 degree, 270 degree, 360 degree, this way also. But usually now, since we started getting on track and we started writing them in radian format, this is actually better way to write. So sine 0 degree value equals to what? Sine 0 degree is 0. Sine 90 degree value is actually 1. So we can actually put, let's say this is our 1. This is 1, and then suppose this is our minus 1. We put minus 1 here. So 1 is somewhere here. And then sine 190 degree, sine 180 degree is 0 again. And 270 degree is minus 1. Then sine 2 pi means 360 degree equals to 0. You can find it out from our unit circle also. Okay, unit circle also this works. If we take unit circle, this way also you can find out all this value, because we know that this value is 1 comma 0, 1 comma 0. So sine is this value. That means sine 0 degree means 0. And this is the 90 degree, and this value is 1 comma 0 comma 1. So this is 0 comma 1, and this is 90 degree. Second value is sine, so 90 degree means 1. This value is minus 1 comma 0. This is 180 degree on this line, because we start our counting from here. So total here is 180 degree, 180 degree. So 180 degree is 0. That's why 180 degree is 0. Okay, this way these are the bigger values of all this sine, like 0, 90, 180 to 7. But now in between this 0 and 90 also we can find out some values, which is done here. This is pi by 6. So pi by 6 means sine 30 degree. So for sine 30 degree, you can see that this is total is 90. So if we separate 30, 60, so it will be somewhat here, and the value will be here. at the half, okay, somewhat. And you can see just roughly just to show you that the graph will just follow this kind of procedure, this kind of path the graph will follow, based on our rough estimation. Of course we can put all the values and check where it goes. So these extra values we need to understand like exactly what is the path that this graph is going to follow. These extra values we need for that. Yeah. So this is how we can graph the sine function, and if we want, of course we can extend our idea, and you will see that actually the graph will start continue following this, because we know that the period of sine function is 2 pi. That means basically from 0 to 2 pi, whatever it is, this same thing will be copied next step. So same thing will be copied here, and same thing will be there in the other side of the graph also, because the period is 2 pi. So period means actually the same thing will be copied after that particular time or particular interval, whatever you prefer to say. Okay, so period actually means that. So let's look at what will be our final graph. Actually, we have the graph in the next page. So I can do this. This is the final graph. So this is the graph. If you draw it, the value by using all the values, by using all the values. And now since this is the period is 2 pi, so actually we can actually continue our graph in the both direction, in this direction and in the negative direction, and from minus infinity to plus infinity, basically the graph will start doing that, and it will continue doing this. This is something like a wave. So a nice wave kind of thing, and it will continue, and the spacing between plus 1 and minus 1, so the spacing will be between plus 1 and minus 1. Within this space the graph will continue flowing. Okay, so the graph will continue. This is the actual graph of sine function, and sine function helps us to understand a lot of natural thing. Do you understand natural thing? You see the wave, the wave things actually start from here, and very interesting way to express the things that we see in the nature. So let's look at what we understand from this graph, or what are the things that we can see from this graph. First of all, you can see that the input of sine function, input of sine x, we can put any value you want here. You can put like 0 degree, 20 degree, 400 degree, 4000 degree, whatever you want you can put here, and some answer will come in the calculator. That's why we are saying that the domain is all real number. But whatever the value you put, your maximum value will be plus 1 and minimum value will be minus 1. Because the graph will flow within this space. That's why plus 1 and minus 1. Inclusive means they are included. Plus 1 and minus 1, they are included. The graph is odd function. You can see this is symmetric with respect to origin. Corner and corner is same. So this is odd function graph with respect to origin. So this is an odd function. Sine function is periodic, and the period is 2 pi. We actually discussed this in our previous chapter also, section also. The x-intercepts are minus 2. So x-intercepts are where? This is the x-intercept, which is 0 degree, then pi, then minus 2 pi, and then it will continue. So the previous thing will be like minus pi. This is minus pi, and then minus 2 pi. These are the x-intercept. These are the x-intercept. Okay. And where we have our 1, so we have our 1 here, 1 here, then we will keep getting 1 like this kind of value after some same interval. That means pi, 5 pi, 9 pi, then you see 13 pi, next number will be 13. So you see plus 4 gap here. And where we get minus 1, so you see minus 1 is here, so there will be another minus 1. If we continue here, there is another minus here. So we understand actually that this value will be repeating, and this is what we mean by this. Where will be minus 1, where will be plus 1. By the sequence, by the pattern, we can actually estimate them. Okay, so these are the things about the sine function. And just to mention, okay, let's not cosine function will also have the similar thing. If you read the book, then you will actually see basically the cosine function. The graph is start from here. If you say graph is start from 0, cosine function graph will start from 1, because cos 0 degree equals to 1. So basically the graph will flow that way. But you will see the similar kind of pattern of properties you will have in the cosine function also, and they will follow the similar kind of thing. Of course, they see they're plus 1 minus 1, but the zeros will not be as sine, but they will be of the same similar interval, just like this. They are really very close to each other, just the starting point and consecutively that kind of thing are different. Okay, now let's look at how do we do the transformation for sine function. Uh, let's say we have a graph like y equal to 3 sine x. Instead of sine x, y equals to 3 sine x. So what will happen for a number here? Suppose 3 sine x, 4 sine x, what will happen? So you see that for this tree, this is actually, it will give a vertical stress, just like the transformation that you studied in I think if you have studied 2.5 from the Sullivan book, similar kind of thing. Yeah. So vertical stress, see this value where it is for pi by 2, this value is at 1, and this value is same, pi by 2, same thing, just the point will now, the graph will be like now, stressed, vertical stress by a factor of 3. So this is the thing what will happen for this. Suppose if it is 2, then at that time the graph will be here. At that time the graph will be here. The graph will go there. So for this value, this is what it does. If we multiply the function by some specific value, it actually gives some vertical stress. Okay, vertical stress. So this value is for vertical stress. We will summarize all of them. Now we have another thing. Now we have minus and then sine twice x. So for this kind of thing, what will happen? Notice that we gave sine also this. First of all, you have to be careful about this minus sign, and then you have to be careful about this number here. This is 2. So for the minus, actually the graph will have x-axis reflection. So this is for the minus. This is the function operation for the minus thing. The graph actually had x-axis reflection. Look at this graph. This is our starting graph. This is the x-axis reflection graph. That means if the graph gets x-axis reflection, this part here will come actually here. This part here will come here. So this is the x-axis reflection. So if you multiply the function by a minus sign, then this red color will be the graph. Just same graph, it will be flipped about the x-axis. The graph will come here. Now for this 2, what will happen for this 2? This is actually a horizontal compression. What does it mean is this? See, look at this. From 0 to 2 pi, we have one wave. Just from 0 to 2, we have one wave. But for this 2, now from 0 to 2 pi, within this space, now we will have two wave. Within this space, and you can see it here. Although you do not see the two waves because the half is shown here. But you can see this is 0, this is pi, 0 and pi. So 0 and pi is already here. Already within this space, now we can see that there is a full wave within this space. There is a full wave now. That means within the next space there will be another wave, another full wave. In other words, for this 2, now in the same period, same space, we will have two waves now. The wave will get compressed. So this is what will happen. This is what is happening here. Okay, so this number will compress the wave. And for this minus, what will happen is graph will have reflection about the x-axis. And of course, if it is 1 by 3, then the graph will be stressed. The graph will be like stressed within the same space. Then you will have more waves within the same period, within the same angle here. If the number is 1 by 3, 1 by 2, when it is fraction, then the value is smaller. When it is suppose 3, 4, 5, then you will see the number of waves are more and more within the same space. Something like this. Suppose you have a wave here. Not a good drawing. So suppose you have a wave here. This is like somewhat frequency, acting like frequency. Okay, we are just somewhat giving the idea of like frequency. Suppose now we can have more waves, like within this space we can have more waves. Okay, so you see almost double, our wave is double here within this space. Can you see? Let me draw it another color. So here, 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 here. Now our waves will be, we will have more waves here. Just suppose something like this. Then this kind of thing. Basically, what I mean is the number of waves is more within the same space, which means the frequency is getting higher. Frequency is getting higher. So this is what this is the thing. This number actually does that operation. This number is doing that operation. Now one more thing, and then we will summarize all the things that all the things like by the transformation what we said, and the other things about the stressing, compression. We will summarize all of them. So how can we find out the amplitude and the period of the sinusoidal function? So all the words are new here. So first of all, amplitude, then frequency, then a period of the sinusoidal function, then sinusoidal. That word is also new to you. This word, this is sinusoidal function, amplitude, period. Okay, so amplitude is actually if you have a graph of something like this, amplitude is the distance from this original line, or from this x-axis, what is the height of this wave, that is the amplitude. Suppose in our regular sine x function, amplitude is 1. Okay, amplitude is plus 1, or yeah, amplitude is plus 1, because you see the modular sign here. That's the amplitude. Period means from the repetition. After how much distance we have the repetition of that wave, that is the period. Sinusoidal function means any function that we can represent by using the sine function's transformation. Suppose a function is here. Suppose some function is here, like this. Now you see this function looks like sine function, but this is not on the line. This is somewhere up. But we can actually bring it here. By using the transformation. We can just simply say that our sine function went there by using the transformation. So this is a wave which looks like sine function. Then this wave will be sinusoidal function. Sinusoidal means the function or the wave that looks like sinusoidal thing, the sine graph. That if it looks like sine graph, then actually we can start working with that graph. So that will be the sinusoidal graph. Now, how do we find out the amplitude and frequency? So you see our graph, our function that we discussed. One method we discussed, y equals to 3 sine x. So you see this 3 is the amplitude. You remember this, our graph actually went 3 unit. Our graph actually there is some like vertical stress like 3 unit. There was this graph went for, you can see 3. If you have this 3, this actually brings our graphs to, for the vertical stress, this goes to 3, and this goes to 3 in the y-axis. So this number is actually will do that work, this thing. Okay, so this is the, and period will get period. The period equals to 2 pi divided by lambda. This is called lambda. This is a Greek alphabet. This is not W. This is lambda. So we have this omega x. We call it a sine omega x. This omega will stand for we can say t equals to 2 pi divided by omega. So if someone give us some number here, suppose 2, 4, 5, 10, we will put that value. Then we can find out the period. Suppose if someone gives us a equals we have an example here actually. See, y equals to 3 sine 4x. So 3 is the amplitude. And period will be what? So you see, instead of omega we have 4 here. So put 4 here. So if you put 4 here, what we get? This is 2 pi divided by 2 pi divided by 4, 2 pi divided by 4, 2 pi divided by 4. So then if you do the cancellation, we will have pi by 2, pi by 2. That means for this math, our amplitude is 3 and period is pi by 2. So this is how we can do the calculation for the period and amplitude. Period and amplitude. Also, if we change the math, suppose if some other value, suppose here 6x or 2, all this kind of thing we can give here, then we can get the period here. Suppose if someone gives you minus, suppose minus 3x, still our period will be plus 3. If someone gives us minus 2, here minus 2, still our period will be plus 2 because we are taking the modulus, because the graph amplitude actually goes up and down, but we can just take the value of how much it goes up or how much it goes down, the distance, we take that distance value. So this is how we can actually find out amplitude and period of sinusoidal function. We just look at these two value. This value is the amplitude, and this value, from this value we get the period. Now if we summarize all of them, we have, look at this. So you will see that I think this is we will not need to mention everything here, but from the idea, suppose x square plus 2, it means our x square graph goes 2 unit up, and same thing here for the sine function. If it is sine x plus k means some number, the graph will have vertical shift, graph will go up, or if the number is down, then it will go down. Minus 2 means the graph will go 2 unit down. So the point here is actually this is same as the thing that we have learned in the transformation of other chapters, like in our quadratic function transformation, even function, odd function transformation, all of them. Here is also, they are also same, nothing new. And within the bracket, if the number is within the bracket, then it is horizontal shift. Within the horizontal shift, then this tells us the amplitude, change in amplitude is how much, that number will be written here, as you can see here also. This will give us the period, this number will give us the period. This is omega, omega is a Greek alphabet. So suppose a equal to 3 given, t equals to pi, and omega equals to 2 given, then how can you write the sine function? How can you write that? See, we can just put the value of a here, a equals to 3, t value you can put here, and then you will see that the same. Omega equals to 2, so we can put here 2, we will get the twice x. That is the function. So if the value is given, this is how we can write it. All right, and so this kind of maths, try to practice. This is section 4.6.4. These are the this is sine function and cos function. Let me graph of sine function and cos function. This will be, page number is correct. This is graphing sine and cos function. Okay, and try to practice this math. 11, 15, 18, 19, all of them are from sine, only sine, because today we discussed only sine, so all of them are from sine. These all maths are from sine. These maths are also sine. You try to solve it, then we will discuss them during the class time also. Okay, and that's all for today. This is the last page of the slide. Thank you all, thank you very much, and have a good day. See you all in the class. Bye bye.